Alright, so the next step in dealing with like terms and exponents and everything like that is we need to figure out how to multiply with exponents. So hopefully you recall from adding and subtracting that if you're going to add exponents together, you just have to make sure that your exponents are like terms. So if we're going to add 2x to the 5th plus 7y squared, could we do that? No, because these terms are not the same. We can't add anything that isn't a like term. However, just like with multiplying with fractions, when you're multiplying with exponents, it doesn't have to be exactly the same. If you have 2x to the 5th plus 4, that's supposed to be a 4, sorry, plus 4x cubed, you could not add those together, but if this were a different problem and this were multiplication, we could multiply those together. So we're going to cover how to do that. The like terms rule does not apply to multiplying the same way it does to addition. So let's look at a simple version with no extra 2's or anything like that. So let's look at y squared. Now, when you're dealing with algebra and you have x's as variables, it can get really confusing to also have x as multiply, right? You can't use both of those. So I need to introduce you to my new favorite sign. It's another way to write multiplication, and it is a dot. This dot right there means that we are multiplying this with whatever is coming after it. So in this case, y squared times y to the 4th. And that solves our problem of not wanting to have an x right there and suddenly wondering, wait, is it y squared x, xy 4? Is it multiplied? We don't want to do that. So this dot means multiplication. Alright, so now we're looking at this problem. When we're multiplying with exponents, we just have to remember what an exponent is. Remember, it's the term or the factor multiplied to itself, and you have however many are the number of the exponent. So in this case, y squared would be y times y, and y to the 4th would be y times y times y times y. Well, if you're looking at that, how many y's do we have? Y times y times y times y times y, that equals 6 y's. So we could rewrite this problem, and the answer to this problem would be y to the 6th, would be a separate way to write this really lengthy and bulky problem. So y squared times y to the 4th would be the same as y to the 6th. Now, if you are paying attention to those numbers, that means that the exponents got added together. So when you're doing y squared times y to the 4th, you can just look at the exponents and think, what's 2 plus 4? Because 2 right here plus 4 right here equals 6. So y squared plus what? Y squared times y to the 4th would be y to the 6th, right there. Let's do another one, just so you can kind of get it in your brain. That explains why multiplying kind of looks like an addition problem when you're dealing with exponents. So let's look at this problem. Let's say we have x squared times, and this is a really important time to use this dot times symbol, because can you imagine if we had x's there? That would be a mess. Alright, so times x to the 5th times x to the 4th. Well, what's the answer to that one? Now you could write out all the x's that are involved here like we did in the y problem. We could be like, okay, so x times x, and then 5x's, and then 4x's, etc. And you could do that if you really wanted to, but you don't really need to, because you can just look at these exponents and think, okay, what's 2, imaginary plus sign, what's 2 plus 5 plus 4? Let's do that really quick. So 2 plus 5 is 7, 7 plus 4 is 11, so our answer to this problem would be x to the 11th power. There would be 11 x's lined up in a row being multiplied together if we were to write all of this out instead of using exponents. Alright, that's pretty simple. You can figure that out pretty easily. Let's look at multiplying something where the factors are different. Let's say we wanted to multiply y squared times x squared. Well, we can do this because in multiplication, it doesn't matter if the terms are like terms, like it does in addition. So can you imagine how we would do this? Well, in this case, it's just a matter of saying, well, if we were to write this out, it would be y times, because of this one, x times x. So what does that equal? Well, if we were to write it with exponents again, y squared, x squared. We just squish them together because they're all multiplied together, so we don't actually need this dot. We can just say y squared and x squared together, that equals the same as y squared times x squared. So that's multiplying two different factors with exponents. You can do the same thing with, let me erase that. You can do the same thing with this one. Now this one's going to be a little bit tricky, but you know how to do it. Alright, a times a squared. What are we supposed to do there? Well, remember that a single a, we could imagine an imaginary 1 up there because we have 1a. We just don't usually write the a because it's a given. It would be redundant to put that a up there usually. But if we needed to, we could say a to the 1 times a squared would equal a to the third, because there would be 3 a's lined up waiting to be multiplied together. Let's do one more. Let's do this one. So we have y squared times y to the fourth times x squared y. What's the answer to that one going to be? Well, if you want to write it all out, you can. It would be y times, thanks to that one, 4y's y times y times y times y times, thanks to that one, x squared times y. Because those are squished together, they're automatically multiplied. What would that be? Be 1, 2, 3, 4, 5, 6, 7 y's and an x squared. So the answer to that would be x squared y to the 7th. But if you don't want to write all of those y's out, just remember, you can say, okay, we have 2 y's, 4 y, and an imaginary 1 right there. So 2 plus 4 is 6, 6 plus 1 is 7, and we could just know that it was x squared y to the 7th. Pretty simple. Alright, now what we would be doing with this once we had figured out and simplified all of our expressions is, let's say that we have a problem that looks like this. And this is why it becomes useful to be able to know how to do this. Okay, so here's our problem. How are we going to deal with this 3 and this 4? Well, it's just multiplied like everything else, right? So if we're going to add these, or merge these terms with multiplication, then we're just going to do 3 times 4, which is 12. And then x squared and x, which means we have x cubed. And y squared and y, which means we have y cubed. And that is how we merge these terms into this with multiplication. Now, how does this become useful? Well, just remember that with anything that we have a variable, let's say we suddenly discover what the numbers go with those variables. So let's say that x equals 2 and y equals this terrible number, 7. I don't know why I did that to myself. I'm just making these numbers up, but 7 is not a friendly number. Anyway, so we have 12, and then we have x is 2, so 2 cubed. And then y is 7, so 7 cubed. And we could solve what that is. I actually don't know 7 cubed off the top of my head, so we are not going to solve this problem, but if you wanted to do the multiplication, you could find out what that is and tell me in the comments of the video if you so desire. Alright, see you guys in the next video.